Okay, so let me ask you this then. For you guys that actually took it, do you, when you get your score back, do you also get something that says, hey, you landed in this percentile or something like that? Like you're in the 80th percentile or what? Okay. So now you're going to see where all that comes from today. All right. Where, how do they rank you? All right. How do they rank you? When a lot of people take, especially a test like the SATs, it falls what's under what's called the normal curve. And you guys see this normal curve here that has numbers on the bottom and certain percents. If you add up all these percents, it's going to be 100. Okay. And they break it up right in the middle here. And you can start making a couple notes here for me. Right in the middle where it says 0, to the left is 50% and to the right is 50%. That 0 is the mean. Okay. That's where the mean goes right there. 50% above, 50% below here distributed. And then you're going to start seeing a half, 1, 1.5, 2. Those are your standard deviations. All right. Those are your standard deviations. So at 1 here, all right, at 1, there's actually going to be a score there. All right. And we did this yesterday. That score is going to be 1 standard deviation above the mean. And if you remember how we did those problems, we took the mean, and in this case, since we're going in the positive direction, we added your standard deviation. I'm just going to abbreviate ST. Okay, so that's, I take the mean, whatever the score is, I add the standard deviation, and that's that score here. And how do you think I get to -1, which is 1 below the mean? How do you think I figure out that score? I take the mean and subtract the standard deviation, yes. So what I need you guys to do for me real quick is from 1 to -1. So within 1 standard deviation, I need you to do a quick calculation for me. So within 1 standard deviation, I need you to add up those percents for me. Okay, within 1 standard deviation. So can you go to your calculator and add up those percents for me? What percent is between 1 standard deviation? Because this is going to be a famous number that you're going to see more and more of today. What are you guys getting? 68.2%. Everyone agree? 68.2 when you add them all up. What's up?
Yeah. What are you adding together?
I'm adding everything in between 1 below and 1 above the mean. So I'm adding 15, 19.1, 19.1, 15. Yep.
So it just says within 1 standard deviation, it's -1 and then +1, those two, right? But
in between those, yes.
Yeah.
That means within.
But if it said within 1 standard deviation above.
Now I'm adding everything up here. Okay. Oh, we'll get there. Okay. We'll get there. Above 1 standard deviation above is all this up over here. Within 1 is everything in between. Below 1 is everything to the left. And we'll get there. What do you guys have? What's your percent? 68.2? Good. Remember that. We're going to remember that number because we're going to see it. All right. Last thing I want to do with you before we get into some problems. How do you think, and you guys are smart enough to do this, how do you think I'd get the score at 2 standard deviations here? What do you think I'd do to get the score there? Go ahead, Gabby. Yeah.
You go from -2 to 2.
Okay, whoa. I'm just asking. So to get from 0 to the score at 1, I take the mean and add the standard deviation. How do you think I get to 2 now? Add the standard deviation again. Okay, and again, just stay with me here for a little bit. So I'm going to do mean plus 2 times the standard deviation. All right, mean plus 2 times the standard deviation. And then to go to -2, what am I going to do? Mean minus 2 standard deviations. You guys will see how easy this is once I actually put scores there. And I need you to do one more favor for me. The last favor here. Can you add up the percentages between 2 and -2? 2 above and 2 below. Within 2 standard deviations. what's my magic percent there? 95.4%. Okay, so 95.4% is within 2 standard deviations. All right, let's have a little fun now. All right, let's get rolling. Everyone good? I have the notes here, and you'll see how this all comes into play right now. Let's do this. Another name for this curve we just used called the bell curve. So that's right up here. Hey, follows a bell curve. So I know now to use this curve. A mean of 80. Where do I put 80? Let's get fired up now. Where do I put 80? Where's 80 going on the curve? At 0. There you go. Replace it. I got you, Paige. I'm just making sure everyone else. It's called the teaching technique. They taught me that at teaching school. All right? 80. Right there at 0. The standard deviation is 5. So if my mean is 80, anybody know what the score is going to be at 1 above? Why 85, Richie? You add the standard deviation. So at 1 above, my score is going to be 85. What about 1 below? What's going to be my score? Oh, all right, we're picking this up now. It's going to be 75. Maybe I need, actually, you know what? Let's do it. What would be 2 above then? 90. Keep adding 5. What, Gabby? 90 at 2 above. What about 2 below? 70. All right. Now, I don't have to do this every single problem. It depends on what the question says. So let's read it. Approximately what percent of the measures fall between 75 and 80? So now I look at where I put 75 and where I put 80. And what am I going to do in between? Add them together. Okay, so did I need to do 90? No. Did I need to do 70? But I wanted you guys to see where it was coming from. All right, so the percentages is going to be what percent fall between 75 and 80? Let's see, I'm going to add 15 with, what's the other one there? 19.1. So what percent of those scores were between 75 and 80 according to the curve? 34.1% of the scores fall between there. Yes, Gabby, go.
Is the normal curve always going to be like this, like 1.7, 4.4, 9.2?
Yes. I'm not going to change those percents on you. Okay? It's always going to be the same curve. But we're going to run into a problem in a minute, but we'll get over it. Next one. A set of scores with a normal distribution. Okay, we got to start looking for some key words too. What tells me to use this darn thing? Bell curve. Normal distribution. All right, they're normally distributed, which means they follow that curve. A mean of 50. Where's the 50 going?
0.
At 0. Standard deviation of 7. Approximately what percent of scores fall between 36 and 64? All right, so I need to label my curve until I see a 36 and 64. All right, what's 1 above going to be? 57. Nope, not there yet. What's 2 above going to be? 64, right? Add another 7. All right, so I don't have to go up to 3. I got it. Let's go backwards now. Below the mean. What's 1 below? What's the score at 1 below? 43? Nope, I'm looking for 36. So 2 below now. 36. And you can add them up, but we've done this already, haven't we? Within 2? We already know that number. What are the percents that always fall within 2 standard deviations, which this is? 95.4% of these scores are between 36 and 64. Ask now. Because I'm not going to make everyone happy right now. Because I got bad news. I'm not giving you this curve. It's not on the formula sheet. It's not anywhere. Do I expect you to memorize it? No. Because look at number 3. Did I copy and paste it on number 3? No, I didn't. So how the heck are we going to do this problem if I don't have a curve to label and add up all the darn percents? Here's how we're going to do it. This bad boy's got a curve already built into it. Okay, it's already in your calculator. It's already built in there. All right, so from now on going forward, any of these normal distribution problems, we're going to use the darn calc. Okay, we're going to use the calculator. It's just a matter of where do I go. Let's do this. Here we go. Number 3, a test was given to 120 students. The scores were approximated. Oh, my eyes light up. Normal distribution, right? Yeah, normal distribution. So I can go to my curve. Mean of 72. What percent scored 65 or higher? All right. So how do I use my calculator? We got to go somewhere new. We do not go to statistics. It won't be there. It's distributions. Hey, normal distribute. We go to distributions, right? Not bad. The calculator's helping us out. And not even only that. Whoa, look at all those distributions we have. You only live at one place, though. Wild guess where you're going to live. Normal. Hey, there we go. So we go down to normal. This thing is just holding your hand. And it needs you to input 2 values. How about that symbol? This is what I really love about the calculator. You don't need to memorize what the symbols are, because right next to it tells you what to plug in. The mean. What's the mean in this problem? 72. So I type in 72. Go down. This little circle little thing stands for standard deviation, which gives you?
7.
Oh, all right. So I plug in 7 and I go to next. Here's where we got to do a little work. Okay? If you notice, if you scroll over to the curve over there and hit the down button, you have 3 options right now. 3. Less than, in between, or greater than. All right? If you go back and read question number 3, we're looking for what? What percent of the scores were 65 or higher? So which choice do you think we want on the calculator? Or higher? The last one, right? And now you just got to tell the calculator, all right, greater than what? 65. Ready? 65. Right? You got to tell it, hey, I want all the scores that are greater than 65. You don't have to plug anything in here because this is where our answer is going to be. So everyone good? So I hit greater than 65, enter. And the only thing you have to realize is it will give you the answer, but will give your answer as a decimal, not as a percent. Okay? It will only give your answer as a decimal, not a percent. So if you're unsure, what can I do here? Multiply by 100. Okay? The calculator will only give you the answer in decimal form, not as a percent. All right? So if you need to multiply that by 100, so about what? 84%? Or 65 or higher. Anything you want to ask? Because this is going to go much quicker now. All right, here we go. Yep, 425 juniors took it. Oh, there it is, right? Where'd it go? If the scores on this exam were normally distributed, so I know I go to my calc here. If Sue scored a 740, what percent of the students scored below her now? Scored below her. So help me with my calculator. All right, I go back. Can I do this? I haven't tried. Yeah. All right, so now, which one do I want now? Scored below then, less than her, right? So this top one. And what am I looking for? The scores that are less than, in her case? So actually, I didn't even, sorry, I got to go back. I can't do this, can I? Why not? I'm learning on the fly too. Yeah, I got to do a new mean and new standard deviation. So just hit your back button, sorry. And what was the mean again? 540. With the standard deviation of 80. Okay, there you go. Thanks, you. And now it's less than, what was her score? 740? Yep. Enter, and then there it is. She's a beast, huh? All right, she got a nice score. Why? About 99% of the people who took it scored lower than her. All right, she's a beast.
Are they allowed to use numerics on the SAT?
I think so. Yeah, if you're on the Regents, I think you're allowed to. I don't quote me.
I wasn't allowed.
No, don't quote me. I don't know. I don't know that. Regents, yes, I definitely do know. All right.
Did you say on the SATs you can use your number?
I don't know that. I'm just saying yes or no. I don't know. Regents exam you can. I don't know. I can find out though. I can find out. All right, and ask me at the end because I thought about you in particular being a junior. And I'll just show you this. Some of you guys are going to be kind of pissed. Some of you seniors, but where is it real quick? Elements. I don't know if this helps, but it's got the whole periodic table on
Are
there.
you kidding me?
And then you
We
go to,
had the periodic table.
and then you go to this. I'm not.
Staircase.
I'm not the chemistry guy, so I don't know if this helps or not, but that, and then you hit
And it's
enter,
colored?
and it comes up with
What?
your atomic number, mass number, molar mass. I don't know if any of that helps, but
It's a graphic calculator though.
Like, why were we made to
So-
struggle?
Oh yeah, wait, we're not even allowed to have like.
Graphic calculator.
Yeah, it's only like.
Oh yeah, it's like one of the like little.
all right, back to here though.
So for
Uh,
class though, like,
We got a problem though, right? And that is, this was not a multiple choice question. And on the Regents exam, you're still going to need to show work. You're just not allowed to write down an answer. You got to show some work. So unfortunately, when we show work, you got to show this graph. Okay, you got to make a picture of this graph. Okay, and that'll be fine to show work. All right, so if you just do a little number line on the bottom, 200, 300, 400, 500, 600, 700, put your line right there, fill in the rest, shade in the rest of the curve to the left, that's fine for work. All right, but we just can't have 99 point,
we have to
whatever.
write the numbers.
okay, so
Do you want us to do that on the test?
yes, if it's not multiple choice. Multiple choice, no work needs to be shown, but yes, I would like you to, just to get in that habit, because you're going to have to do it in January on the Regents exam. Because I guarantee there'll be a part 2 question, a normal distribution question that you got to show work for. Okay? But I think that's the least we could do, given the calculator's doing it all for us. And you get to show off your artistic ability. There you go. Try to make it look like a curve, all right, not a couple of valleys and hills, you know? That'd be great. I just want to make sure we're all set for the next one, because the next one's a little different. Is everyone all set? Okay. This next one, finding the percent is not good enough. Okay, finding the percent is not good enough on the next one. This is the top. This is where I need you to be here. Where finding the percent on your calculator is not good enough. Read through it here with me. All right, the amount of soda normally distributed, so I know where do I go on my calculator. We got the mean, we got the standard deviation. If 250 cans are pulled, how many can expect to be less than 11.1? So I don't care about the percent here. I want to know how many of these cans are 11.1 ounces or less. Find the percent first. All right, let's find the percent like we usually would do, and then maybe you guys can help me find the actual number of cans. All right, so let's find the percent. Let's go back to our mean. You guys got it. I don't have my notes in front of me. What do we got? Mean again? 12. SD here, standard deviation. 0.4? 0.6? All good so far? Next, we want what? Less than, right? Less than 11.1. So I want to keep that there. And then it's 11.1, right? Right? Okay, so 11.1. That's not how many cans, obviously. That's your percent as a decimal. So if I multiplied it by 100, I'd get what? About 6.7%? Everyone, yes? 6.7%? Grant, 6.7%? Okay, but it's 6.7% of how many cans did I take out? Of 250. I need you to calculate that for me now. All right, so the percent will get us to the final answer. All right, so it's not just always finding the percent every time. It's finding how many sometimes. So you guys, can you help me out? What do I do with that 6.7 and the 250? How do I find how many cans? Multiply what? 0.067 times the 250. Yep. And I wish there was a way you could copy this and then bring it to the calculation. I don't know if there is or not, but.
So like 17.
Oh, there is a copy. I wonder if, hold on. Let's see here. Shift copy. This would be unbelievable. Calculation. Nope. I was going to go nuts. There's no copy paste there. Can't paste it.
It worked on mine.
Grant, no, it did not.
0.066807.
Did you copy it from?
Yep, times 250, and I got 16.701.
Yeah, there you go. I just had to allow my screen. That's what I thought. Grant, get out of here. All right, I can do it too. So I guess you can copy and paste it if you wanted to. All right, copy and paste. So how many cans here? How many cans?
About 7.
About 17 cans. All right. Okay, here we go. Let's see who's on top of their game here. Mean is 56, standard deviation is 5. In which interval do 95% of all cases lie? I don't know. Calculator's not really going to help us out here much. We already know. Hey, we already know our percent. I'm looking for the interval. All right, and so basically going in reverse. You know the percent. What interval did I start with? And look, the percent's always going to be a certain number. It's something we're going to be familiar with. Hi, we've seen that interval before. We've seen that percent before. Where did we see it? Within what? 2 standard deviations. Yep. I'm not going to give you a random percent. It's either going to be the 68% or this 95. So can you guys help me find that interval that's within 2? So let's draw yourself your own little curve here. What's in the middle of it? I know that, but in this case?
56.
So 56, right? And we're looking for what? Between 2 and -2, right? Within 2 standard deviations. So how do you find it at 1? How do I find that score at 1? 56 plus 5. There's 1. I got to go out to 2, though. So what do I do with the 61? Add 5 to it again, so 66. Then got to go to -2. How do I get to -1 first? 56 minus 5, so 51, and then finally 46. So what's my interval? 46 to 66. Again, I will not, I'm going to ask this question of you, but it won't be some random like 80%. It's either going to be 68.2 or 95.4. You just got to watch out for those numbers. All right. Other than that, determine what, I don't think I'm going to do 7 with you. All right. I'm not going to do 7. Nope, it won't. Nope. Okay. Nope. I want you guys practicing your calculator on your own here. Let's get rolling. Okay. Yeah, hurry up. And hey, what's the deal with breaking my dart too? I just found that out today. Yeah, I had to order new ones on Amazon. You could have at least let me know.
Was that when you weren't here?
Probably. Keep your paws off it or you're going to have a broken wrist. All right, you don't have to worry about the broken dart.
I can take one. Okay. So like